Good afternoon, everyone. Thank you for joining today's Resideo webinar session, where we are going to talk about top call drivers. My name is Fatima Guevara, and I am part of the Resideo training team. And on behalf of all of us, I'd like to welcome you to our training session today. Information on our upcoming webinar sessions are posted on our website at resideo.com/webinars. You can find upcoming webinars by searching under the Discipline tab by the title HVAC or Plumbing on the left-hand side of the search bar. So be sure to register. You can find the recorded webinar sessions on this same website by selecting On Demand on the right-hand side of these filters. For those contractors joining us for today's live session and you are interested in earning one NATE continuing education credit, there are a few things to know. If you provided your NAT ID on your registration form, we will submit those details to NATE, and we don't need any additional information from you at this time. If you did not provide us with your NAT ID on your registration form for this webinar and you would like to receive credit for attending our live session, then we ask you to email your first name, last name, NATE ID, and the date of the session you attended to homes.university@resideo.com within 1 week from today. This information is submitted to NATE 1 week following the close of each live session. Any request sent outside of 1 week from this live training cannot be processed. As a reminder, we can only process requests for NATE credits when you attend the live webinar sessions, and we are unable to process requests for watching a recorded version of the trainings. If you would like more information about the NATE program, please visit their website at www.natex.org. One quick note before we begin the technical presentation, all attendees are muted. However, if at any point during the technical presentation you would like to ask a question, please use the Q&A feature found in your Zoom webinar controls. We are reserving the last few minutes of our time today to answer your questions. So as we progress through the technical training today, please be sure to ask your questions in the Q&A feature so we can address it at the end of today's session. So now we're going to turn things over to Steve Kath, who is the product support specialist on combustion and water products. Steve is going to be sharing his knowledge of our top call drivers today. So Steve, we're going to turn things over to you.
Thanks, Fatima. Welcome, everybody. I hope you're having a great day so far. The products we're going to go over are, you see on the line, some things about gas valve, S8610U, S9120, AQUASTATS, and the zone valves. And what we wanted to cover in this presentation are some of the common or regular troubleshooting calls we get on the technical support line for Resideo at our tech center. We find that if we can help you folks in the field or at the distributor level, when you get calls like this, if we can help speed the process, that's really what we want to do for you guys. And the first thing to launch right into it that we want to go over is involving the tried and true S8610U 3009 ignition module. And a fairly common question we get, or situation we get, like you see there, the S8610U 3009 has just been installed. There's a call for heat, but only the pilot light comes on. The main valve just doesn't open. Goes through a 90-second trial, has the 5-minute delay, and then it tries again with the same results. It's a pilot flame only, and no main valve opens. With a scenario like that, one of the things we can be looking at is what we'd call a flame rectification or a flame proving issue. And it's all keyed off of the pilot flame. Now with intermittent pilot, we have, when there's a call for heat and the pilot flame comes on, the presence of the pilot flame is detected by what we call flame rectification. And that occurs when the voltage is passed through the flame and it gets rectified from AC to DC. And we're talking about a pretty small amount of current here, maybe 2 microamps DC. And that microamp, that current can only be present if a flame is there. And to go over a little bit about flame rectification, what happens is when current is passed from one electrode to the other, where the one electrode, in this case the ground, is at least 4 times larger, and the current can no longer flow both ways. It now gets rectified into DC voltage because it can only go one direction. And it's that rectified voltage that the module is looking for to prove that the pilot flame is on, and it can then open the main valve. And what we have here in this slide is a simplified scenario of what happens. You can see out of the module, you've got the spark voltage, the igniter and sensor up at the top, the pilot flame. And because the ground is bigger than the other side, the voltage gets rectified from AC voltage coming out of the module to DC and comes back from the pilot burner bracket, on a wire to the ignition module. And it's that wire that you see leading back to the module that's really the important part, because if that voltage doesn't get to the module or it decreases to a really low level, the module can't tell that the pilot flame is on, and it won't allow the main valve to open. And it's this burner ground wire, the wire that goes from the 4th terminal or the G&D BRN or burner ground terminal, that's a really critical part of the flame rectification or flame proving signal. And with that small amount of current, that wire must go from the burner ground terminal, terminal 4, to the pilot burner bracket, and only to that pilot burner bracket. And a number of calls we get, it's not uncommon that the wire goes from the ground terminal, burner ground terminal on the module, to the gas valve, the furnace chassis, or some other location. And when that happens, when it's wired that way, the current cannot get back to the module, and the module won't open the main valve. And sometimes what we also hear happening is there may be a wire that goes from the burner ground terminal, 4th terminal on the module, to the pilot burner bracket. But we also get calls on occasion where there is more than one wire going from either the pilot burner bracket to the furnace chassis, or the burner ground terminal to the furnace chassis. And when that happens, the microamps drop to a level such that the main valve, the module can't sense that it's open, the pilot's on, and it will not open the main valve. Again, we just want to emphasize, in a scenario like this, one wire from the burner ground terminal to the pilot burner bracket. And as you look at the diagram here, you might see, well, there should also be a ground going to the furnace chassis. Look at the pilot burner ground. No, it doesn't need to be there, because the pilot burner bracket is typically already mounted on the furnace chassis. Next up, again, this will involve the S8610U, but we still get calls on a installer who has replaced one of our vintage intermittent pilot modules like the S86H. And in this scenario, the installer has decided to replace the old one because they had proper voltage at 24V terminals. The igniter is sparking, but there is absolutely no output at the MVPV and the PV terminals. There's just, they've taken everything off. There's still no output. Diagnosis, You see there is a failed module. So what they've done is gone out to the service truck. They've grabbed an S8610U out of their truck inventory. They've put it in. They wired it just the same, MVPV, the valve terminals to the valve terminals. Ground terminal was perfect. And they took the wires off the 24V terminals, put them on the 24V terminals of the S8610U. Thermostat makes a call, and the module doesn't react at all, doesn't even recognize the call for heat coming from the thermostat. And what we need to keep in mind, or what happens in this particular case, is the 24V terminals, like you saw in the S86H, or in this case, the G, you have the two 25V terminals, which is where the W wire from the thermostat went, and R from that power went to the other one, so you had a complete circuit. And what happens with that, and because there are some different wirings, just a little different on the S8610U, we get no call for heat. And what happens there is that on the S8610U, what you want to do is take the wires that were on the two 24V terminals, and you want to put them, what's coming from the thermostat goes on TH-W. You could almost look at that as thermostat W wire. And the 24V ground wire is the common side of that power source. So when you have it like this, the ignition module will recognize, the call for heat, and will then begin to energize the module, start sparking, and provide voltage to the MVPV and the PV terminals. That second 24V terminal, just terminal 6, if you will, in this diagram, would be used if you have a damper wired up to the S8610U. And that's what we have in this scenario. You can see how the damper gets power right off of the hot side of the transformer there. So when there's a call for heat, that tells the module to power open the damper. When the end switch on the damper is made, it then would allow the call for heat to continue on at the ignition module. One last scenario with the S8610U is what you see here. Service tech has installed it. Everything's working, but they're experiencing power on the PV or MV terminal, and they're curious as to why it's happening. Why are they getting power on the PV or the MV terminal? And what we've got here really is a feature in the S8610U due to the new ignition circuitry, because it's got a little microprocessor in there. And as you see there is circuitry in the S8610U that allows it to test whether valve relay contacts are welded or not, which provides you, the installer, added safety so that it won't light off if a valve relay contact is detected as welded. And so, we need to see NO contacts on the valve. And what the module does is it puts a little voltage on the PV or MV terminals that you would sense with a typical VO meter on the those terminals. And it's a pretty small amount of current. You might be getting maybe 13 volts. And it will happen whether there's a valve on there or not. And it's perfectly normal to experience that voltage on those terminals. And a question might come up is, do I need to worry about the valve opening with that amount of voltage? No, with that small amount of voltage, the valve should not open. But the key here is that we want to bring to everybody's attention is this is a safety feature for the module that helps determine, whether or not there are welded contacts in the valve. So it's not opening, it's not operating incorrectly, and there really is no potential for the valve to open in this particular case. Next up, what we want to go over are something about step opening valves. If you've been in the business for a long time, you've been through school as a distributor and a seasoned service tech, we all know you can't convert a step opening valve from natural gas to LP or vice versa, from LP to natural. But the question comes up, do we really know why? And so we thought it might be useful to go into information about the step opening valves and why, what are some of the inner workings that would help us understand why you can't really convert it. In one aspect, yes, it's pretty simple. You take out the regulator screw and you put in the appropriate one for the gas that you're changing the valve to. But what we have in step opening valves is they have a step assembly inside them that non-step opening, standard opening valves or slow opening valves simply do not. And even within each step assembly, a lot of valves use the same housing assembly and a very similar timing diaphragm assembly. Where the difference really occurs is within each timing diaphragm assembly, there is a diaphragm assembly or a low regulator, if you will, which is where the step set point is controlled by the valve. And this provides a timed outlet pressure at the start of each cycle. So the main burner ignites at a reduced outlet pressure. And that step regulator is used alongside a standard regulator to provide the step and the full rate settings. And these valves are connected in series so that when the second auto valve is energized, your step regulator begins regulating while the standard regulator is opening. And simultaneously that step timing diaphragm begins inflating, approaches the step regulator diaphragm, and when the contact is made, the step regulator is forced wide open, which allows the standard regulator to begin regulating. And it's because of those timings and the interconnection there that are based on a particular type of gas, be it natural or LP, that if you were to try converting it to a different gas, the timings, if you will, how the diaphragms, inflate and approach their proper settings, that it would no longer work properly. So, that's we thought it might be useful that, said we all know you can't, but now we kind of have a little more information as to why you can't do that. So, and moving on, the next bit we'd want to go over is the fan timer board, the ST9120U1011, and the J1 jumper plug, which is used in some of the universal applications. In the picture here, you see the ST9120 with the J1 jumper plug in the lower left-hand corner. Now that plug is keyed so it can be installed only in one manner, just like you see there. And when it's installed like this, you see there is a jumper that goes from the upper left-hand corner to the lower right-hand corner. The confusion comes in that in some drawings, you have images that show the jumper wire going from the upper right-hand corner to the lower left-hand corner. And we get calls that installers have tried to force that Molex plug under the receptacle. It won't work, won't fit. And a lot of occasions they'll install it in the one way it can, but then they take the jumper out, they pull it from the upper right and lower, the upper left to lower right corners, and flop it to match to the drawing that they've seen, where it goes from the upper right to the lower left. And we just want to communicate in this scenario. The image you see here, the way it mounts in when it plugs in, so the jumper goes from the upper left to the lower right, is correct. And please don't take the jumper out and try and reinstall it to go from upper right to lower left. That basically renders it useless. So again, just some heads up is that if you run into a scenario where you're installing it, it doesn't match, this is the image you want to see, that, install it the one way it will fit in there. The jumper goes from the upper left to the lower right corner. Moving on, the next bit of information we wanted to present that we get calls on with some regularity is with mechanical triple function AQUASTATS like the L8124, the high limit, the low limit, and particularly the low limit differential. There can be some challenges about that. And the high limit differential, like you see there, it's pretty straightforward. You set the appropriate high limit. Usually it's based on what the OEM might recommend, and the differential is almost always, it's fixed in the mechanical ones. It might be 8 degrees, it might be 10 degrees. In this example, common setting for the high limit would be is usually around 180. And if you have, the high limit differential is fixed at 10, how it operates is straightforward. Water temperature gets to 180. When it does that, the burner circuit breaks and opens. When the water temperature drops that 10 degrees for the differential down to 170, the burner circuit remakes, and it could continue 5-minute boiler if there was a call for heat or you've gone out on low limit. The challenge comes when we get to the low limit and the low limit differential. And that's because the low limit differential is both subtractive and additive, which can be a bit of a challenge figuring that out. And when we have low limit differentials, the differential is adjustable and typically has a range of 10 to 25 degrees. Again, that can be both subtractive and additive. When we're looking at a low limit differential, the first 10 degrees of that differential is always subtractive. And really, as we see there, regardless of what the low temperature, the low limit is set at and the differential are set at, water temperature will always have to drop 10 degrees before the AQUASTAT would open up R to W, preventing the circulator from coming on in a call for heat, and closing R to B so it would bring the burners on. As an example, say your low limit is 140 degrees. You have it set, the low limit differential set at the minimum of 10 degrees. What happens is that when the water temperature drops 10 degrees down to 130 degrees, it would open R to W and close R to B, bringing on the burner to bring the water temperature back up to the low limit setting. And when the water temperature rose that 10 degrees, the burner would open and shut off, and the R to W switch would close, which would allow the circulator to come on if there was indeed a call for heat. Where the difference or the challenge comes in will be if you have a differential larger than 10 degrees. As we see there in the example, we'll use 140 degrees, real common setting for low limit in a mechanical system, then you have the differential set at 15 degrees. What that translates to is when the water temperature drops to 130, that's your 10 degrees, R to W would open and R to B would close to bring on the burner. Now, the burners would stay on and they would run until the water temperature got to 145. There's your that's where the addition comes in. That 5 degrees gets added on. So you have to go from 130 up to 140 degrees. There is that 15-degree differential. And so that's the part of it. And sometimes that adding, the additive part of the differential can be the challenge to add the, get the low limit temperature set right. Sometimes what can happen is, you may want the water temperature to come on at, say, 150 degrees, but you want it to shut off at, say, 130. So, what you may have to do is you would set, the water temperature again at 140. At first 10 degrees, it would drop to 130. And then when the water temperature warmed up to 150 degrees, you'd have to choose that 20-degree low limit differential to get those options in the low limit, so your water came back up at 150 like you wanted. We're going to move on to the R7284U, the oil primary control that we have here at Resideo. And one of the questions we get with some regularity is why the display shows standby even though the thermostat is making a call for heat. And part of that really is related to the R7284 being installed and replacing a mechanical model like the R8184G, whose wiring and schematic you see to the right there. And you see how you've got L1 coming into the black wire. And in series on L1, you have a limit terminal. L2 goes to the, one side of the ignition and the burner motor, or even the oil valve, if there is one installed. And what happens in cases like this, where the installer has put in an R7284U, is they're running into a control that now has a little bit different terminal because of the microprocessor. In this diagram you see, and this is taken right from the 7284U install guide, is, you see the old school one that doesn't have a limit terminal, and how they've taken the L1 and go right to L1. It goes right through the AQUASTAT. But with the R7284U, you need to see proper voltage at L1 and L2, but now you also need to see voltage on the limit terminal. And it's that limit terminal that is really key to the device operating properly. It's when there is an absence of voltage on that limit terminal that the device shuts down, goes in standby, or ends the call for heat. And so you have to do it that way. And the concern, I shouldn't say the concern, but the comments we get is, well, my old device never had a limit terminal. And while I'm not a code expert, there is, in the number of years I've been at this, in every application I've run across, there's always been a limit installed, and typically on the L1 wire in series with that, which, the installer's right, they didn't have a limit terminal, but they did have a limit. With the R7284U, or the P like you see there, that has a limit terminal, you have to wire it like that way. What was on L1, as you see there, goes to the limit terminal, but upstream of that, you run a jumper wire, if you will, the pigtail, whatever you want to call it, from the incoming side, the upstream side of the limit, to the L1 terminal. And what we have here, this is an image taken right from a terrific document that's available at customer.resideo.com that gives you a really good reference as to how it needs to be wired, and using the actual colors that you see on the terminals for the R7284U. So, you know, what you might want to do if this is a control you install with some regularity, you might want to go grab this literature, download it, or work with your rep. Maybe you can get a few copies, put it on the counter, or put it in each of the service trucks, so you've got a reference for it there. Finally, on the R7284U, one last one here. Customer, you know, the installer has just put one in, replaced our friend the R8184G, or even an R7284A. And when the call for heat's made, the display shows hard lockout, like you see in this slide here. With the R7284U, hard lockout can come up for a number of reasons, like you see there. A failed ignition temp, flame sense during the valve on delay, flame sense during the burner off delay, welded burner contacts, or if there are a number of recycles, it's exceeded that maximum number. And with the, you know, one of the things to consider with the R7284U, because it's now got a microprocessor, you do have additional installation options that you can set up on it that you just didn't have in some of the older mechanical ones. And it's that we, you know, in this particular case, can really contribute to what we're seeing here. And the feature I'm talking about in this place is the valve on delay. The R7284U has the option of setting the valve on delay in increments of, you know, 5-second increments from 0 to 30 seconds. And it does come defaulted to 15 seconds on. And what we see happening when somebody calls with a hard lockout is that they installed the 7284U just like the old one was installed. And you can see here, like an R7284, there's a separate valve. You can see how it was wired in, so that when the burner motor was powered up, the valve came on. And you can see in an R8184 in the lower right-hand corner, you see how it would happen there. And what happens is, in this particular case, if you've got the valve on delay configured for on, and you wired it like you saw previously where it was tied to the burner motor terminal, what's happening is that burner motor gets energized, valve gets energized, ignition's going on, and now all of a sudden the 7284U is seeing flame when it's being told, no, the valve shouldn't be on for X number of seconds more. And it sees that, goes into hard lockout, and shuts down the device, giving you that hard lockout error message on the display. Now, you know, if you don't have a valve, you know, you might want to set that option for 0. If you do have a valve and it didn't have a delay, put the valve on the valve terminal and set the, you know, valve on delay appropriate for how the old system was wired. So, you know, again, it's a case of the microprocessor in the 7284U has given us additional features to fine-tune the operation of the system from what you didn't have with the the R8184, or even some of the earlier electronic ones where you didn't have the option of a separate valve terminal and configuring valve on delays. So this is just one where if you have a valve, put it on the valve terminal. Even if there's 0 valve on delay, set it, put it on the valve terminal, then go into the valve on delay and configure that so there is no delay. Next up, one of the things we want to go over is when you're replacing a power head on our V8043 zone valves, whether you have the Series 5000, which you see in the top right there, or the Series 1000, replacement starts with taking off the old power head. And with the 5000 series, it's really pretty easy. You have a spring lock button clip, if you will, there. All you have to do is you press that button, you pull off the old power head. With the 1000 series, you take off the cover and you have some screws in each of the corners that you loosen and you pull off the power head. And what we have happen every now and then is people buy the power heads, they want to bench test them before they put it on the valve. And they can do that a couple of ways, either putting power directly to the power head, the wires that would energize the motor, or using the lever that manually opens the valve. And what happens is the gears strip. We get the call saying, I tried to test this, I put power on it, I used the manual open lever, and the gears stripped. For the valve, for the power head to be properly tested, you have to put the power head on the valve. When it's on the valve and it's properly coupled, the gears won't slip. So again, you buy power heads, you put them on the valve before you test them. If you call and you say, I put them on the valve and the gears are still stripping, you'll get our attention. The other thing that I wanted to go over here as we get close to the end of our troubleshooting scenarios is the manually open lever. That when you move that lever to open, it puts the valve in the service position so that water can flow through if you need to, or in the case of the sweat valve, you can sweat the valve into position without damaging the rubber ball inside the valve. It does not close the end switch. To close the end switch on the valve, you have to energize the motor, and it will drive the little lever inside there so that it depresses the end switch in the valve. That brings us to the close of our call drivers here. I hope that's been useful information for everybody.
Thank you, Steve, for walking us through this presentation training today. If you are interested in finding more information about the products and accessories covered today, you can find that information on the new Resideo Pro website. In this case, we don't have any questions. So thank you, Steve, for providing another great training today. If you think of a question after the close of this training, please reach out to your local Resideo sales rep or send an email to homes.university@resideo.com, and we will make sure to get your questions answered. Training is something we are very passionate about at Resideo, and we want to make sure that you have access to more in-depth trainings on our products. Inside of our online learning platform, you will be able to find many in-depth technical and sales trainings. You can access this online training catalog by visiting the training page on our Resideo Pro website. The first time you access the online training catalog, you will be asked to create an account. And going forward, you will log into your training account to access these trainings. Currently, we have about 20 online learning modules available, including several modules on our humidification portfolio, the T10 thermostat, and the Prestige IAQ thermostat. These online trainings cover everything from technical and installation details and shows you how to identify the right customer and sell these products. We're very excited to add this online training catalog to our training offerings for all of you. If you're interested in more in-depth trainings, we encourage you to sign up for the Resideo Pro Portal account to access these trainings. Also, if you are a Resideo Perks member, you will receive training credit when you enroll and take these online trainings as well. To find more information about our upcoming webinar sessions, please visit resideo.com/webinars. And if you search by HVAC or plumbing tabs, you will find the details for our upcoming sessions. Additionally, we record each of these sessions, and you can find those recordings on this same website by filtering for webinars with the label on demand. One last reminder for those contractors who did not include your net ID on your registration form and you would like to receive credit for today's session, please send an email with your first name, last name, your net ID number, and the date of the session you attended to homes.university@resideo.com within 1 week of today's live webinar to receive credit for attending this training. Once our training session ends today, you will be prompted to complete a survey regarding our webinar session. Please take a few moments to provide us with your feedback on the training you participated in today. We are very interested in your feedback on today's session, and we use your feedback to help us create future trainings. So your feedback is important. Finally, you will receive an email from us in a few days with some follow-up information on the products we reviewed today, as well as the link to the website for information on our future webinars. On behalf of all of us, we want to thank you for joining our webinars this year and look forward for your participation on our upcoming webinars for 2022. Stay tuned for upcoming updates on resideo.com/webinars. Thank you all for joining today's Resideo webinar session and happy holidays.